Let's say that your friend is practicing math, you know, doing some practice problems for a test, and they ask you to make up a function. Then you say, okay, well, how about f of x equals, the square root of x plus 5. Okay, but then you remember that this friend borrowed some money from you and never paid it back. And so you're kind of cranky and not very favorable towards this person at the moment. So you decide, oh, you know what? That's a little too easy. I'm going to make this a lot worse for this person. So here comes my function. My function is going to look like the square root of x plus 5, but only up until we get to x equals 3. After x equals 3, it's going to change entirely to x squared minus 2. And so I'll give them some more details. So the square root of x plus 5 version will be valid as long as x is less than or equal to 3. But then once we pass x equals 3 and go to x values that are greater than 3, the function is going to change and become x squared minus 2. You have just invented a piecewise function. Piecewise functions tend to drive people nuts, and I think it's because of the options and the brackets. But remember, functions are just engines. Okay, all a function like this does, which is an engine that takes inputs and produces outputs, is it just gives you a choice of what recipe to use depending on what input the function is seeing at the moment. So if I wanted to go to this function and ask for f of 7, what I would do is go look at the function and say, okay, I'm trying to plug in 7. Which bucket of input does that fall into? Does that fall into this bucket or this bucket? Well, it falls into the second bucket. And so f of 7 would be 7 squared minus 2, because that's the recipe that we use for x values bigger than 3. Now, that happens to be 47, but who cares? Maybe I want f of 1. Well, again, I just have a choice. Which recipe am I going to use? Well, that's based on the input. My input is x equals 1 at the moment. Which bucket is that in? Is that in this bucket? No, it's in this bucket. And that means we use this recipe. And so f of 1 is the square root of 1 plus 5, which is 6. But again, who cares? That's not the point. The point is that piecewise functions aren't really bad or nasty. They're just functions that give you choices of which recipe to use depending on what your input value looks like. Graphically, all we would do to build this graph is have this curve in action up until that location, and then have this curve in action up to that location. So well, let's make that up. How about something like this? Now you should be noticing something interesting about the first part of that function. This part has a square root, and it's valid for x less than or equal to 3. Now, when x is less than or equal to 3, we're good for a while. We can plug in all these x values, but once we get to 0, we cannot use any negative x values because we can't do the square root. So this whole part of the axis is just ruled out for this function. We don't see it. When x is 0, the value of square root of x plus 5 is 0 plus 5. And so we have that point. And the square root function just kind of goes up gently, sort of like that. Whoops, but I went too far, didn't I? Because when we get to x equals 3, I don't want this curve anymore. I want to switch to x squared minus 2. When x is 3, x squared minus 2 is 7. Which is right about here. And then I will switch to the parabola x squared minus 2 for x coordinates beyond 3. I've left a little open circle, and I would put a closed circle there to indicate that x equals 3 itself gives you a point on the top recipe, square root of x plus 5. So the graph of this has a break in it at x equals 3. It would be nice if the function was set up that we could segue from one segment to the other smoothly at that point, but that's not necessary. And in fact, here we're seeing it not happen at all. But that's how piecewise functions work.